雨。
Over the course of our lifetimes, our bodies undergo a series of extraordinary metamorphoses. We grow, experience puberty, and many of us reproduce. Behind the scenes, the endocrine system works constantly to orchestrate these changes. Alongside growth and sexual maturity, this system regulates everything from your sleep to the rhythm of your beating heart, exerting its influence over each and every one of your cells. The endocrine system relies on interactions between three features to do its job: glands, hormones, and trillions of cell receptors. Firstly, there are several hormone-producing glands, 3 in your brain and 7 in the rest of your body. Each is surrounded by a network of blood vessels, from which they extract ingredients to manufacture dozens of hormones. Those hormones are then pumped out in tiny amounts, usually into the bloodstream. From there, each hormone needs to locate a set of target cells in order to bring about a specific change. To find its targets, it's helped along by receptors, which are special proteins inside or on the cell's surface. Those receptors recognize specific hormones as they waft by and bind to them. When this happens, that hormone-receptor combination triggers a range of effects that either increase or decrease specific processes inside the cell to change the way that cell behaves. By exposing millions of cells at a time to hormones in carefully regulated quantities, the endocrine system drives large-scale changes across the body. Take, for instance, the thyroid and the 2 hormones it produces, triiodothyronine and thyroxine. These hormones travel to most of the body's cells, where they influence how quickly those cells use energy and how rapidly they work. In turn, that regulates everything from breathing rate to heart rate, body temperature, and digestion. Hormones also have some of their most visible and familiar effects during puberty. In men, puberty begins when the testes start secreting testosterone. That triggers the gradual development of the sexual organs, makes facial hair sprout, and causes the voice to deepen and height to decrease. In women, estrogen secreted from the ovaries signals the start of adulthood, it helps the body develop, makes the hips wider, and thickens the womb's lining, preparing the body for menstruation or pregnancy. An enduring misconception around the endocrine system is that there are exclusively male and female hormones. In fact, men and women can have estrogen and testosterone, just in different amounts. Both hormones play a role in pregnancy as well, alongside more than 10 other hormones that ensure the growth of the fetus and natal growth, and help the mother feed the child. Such periods of hormonal change are also associated with fluctuations in mood. That's because hormones can influence the production of certain chemicals in the brain, like serotonin. When chemical levels shift, they may cause changes in mood as well. But that's not to say that hormones have unlimited power over us. They're frequently viewed as the main drivers of our behavior, making us slaves to their effects, especially during puberty. But research shows that our behavior is collectively shaped by a variety of influences, including the brain and its neurotransmitters, our hormones, and various social factors. The primary function of the endocrine system is to regulate our bodily processes, not control us. Sometimes disease, stress, and even diet can disrupt that regulatory function, however, altering the quantity of hormones that glands secrete or changing the way that cells respond. Diabetes is one of the most common hormonal disorders, occurring when the pancreas secretes too little insulin, a hormone that manages blood sugar levels, and hypo and hyperthyroidism occur when the thyroid gland makes too little or too much thyroid hormone. When there's too little thyroid hormone, that results in slow blood pressure, fatigue, and depression. And when there's too much thyroid hormone, weight loss, sleeplessness, and irritability. But most of the time, the endocrine system manages to keep our bodies in a state of balance. And through its constant regulation, it drives the changes that ultimately help us become who we are. If you want to learn more about the ins and outs of the human body, start with this playlist, or subscribe to our channel to keep your finger on the pulse. Muscles. We have over 600 of them. They make up between 1/3 and 1/2 of our body weight. And along with connective tissue, they bind us together, hold us up, and help us move. And whether or not bodybuilding is your hobby, muscles need your attention because the way you treat them on a daily basis determines whether they will wither or grow. Say you're standing in front of a door, ready to pull it open. Your brain and muscles are perfectly poised to help you achieve this goal. First, your brain sends a signal to your neurons inside your body. When they receive this message, they fire, causing muscles to contract and relax, which pull on the bones in your arm and generate the needed movement. The bigger the challenge becomes, the bigger the brain becomes, and the more motor units it rallies to help you achieve your task. But what if the door is solid? At this point, our muscles alone won't be enough. So before you heal other muscles, plant your feet, tighten your belly, tense your back, generating enough force to make it open. Your nervous system has just leveraged the resources you already have. Other muscles need to demand. While all this is happening, your muscle fibers undergo another kind of cellular change. Acting exposed to stress, experience microscopic damage, which can miscause.
Holy shit, that's tanky.
Cells release inflammatory molecules, cytokines, that activate the immune system. This is when the muscle building magic happens. The greater the damage to the muscle tissue, the more the body. The resulting cycle of damage and repair eventually makes muscles bigger and stronger as they adapt to progressive.
Damn, what's my damage?
Since our bodies have already adapted to most everyday activities, those generally produce enough stress to stimulate new muscle growth. So to build new muscle, a process called hypergrowth, our cells need to be exposed to higher work loads than they used to. In fact, if you don't continuously expose your muscles to some resistance, a process known as muscular atrophy. In contrast, exposing the muscle to a high degree of tension, especially while the muscle is lengthening, also called an eccentric contraction, generates effective conditions for new growth. However, muscles rely on more than just activity to grow. Without proper nutrition, hormones, and rest, your body would never be able to repair damaged muscle fibers. Protein in our diet preserves muscle mass by providing the building blocks for new tissue in the form of amino acids. Adequate protein intake, along with naturally occurring hormones and insulin-like growth factors.
What the fuck? FPS stop.
Help shift into a state where tissue is grown. This process, especially at night while sleeping. Gender and age affect this repair, which is why young men with more testosterone have a leg up.
Okay, well.
Genetic factors also play a role in one's blood muscle. Some people have more robust reactions to muscle and are better able to repair and replace damaged muscle fibers, increasing their muscle potential. The body responds to enhancement. If you tear your muscles up, rest, and
Why you so gay?
conditions to keep muscles steady and strong as possible. It is with muscles that growth requires challenge and strength.
みんなの祝福を胸に前へ進むよ。
Charles Osborne began to hiccup in 1922 after a hog fell on top of him. He wasn't cured until 68 years later and is now listed by Guinness as the world record holder for hiccup longevity. Meanwhile, Florida teen Jennifer Mee may hold the record for the most frequent hiccups, 50 times per minute for more than 4 weeks in 2007. So what causes hiccups? Doctors point out that a round of hiccups often follows from stimuli that stretch the stomach, like swallowing air or too rapid eating or drinking. Others associate hiccups with intense emotions or our response to them, laughing, sobbing, anxiety, and excitement. Let's look at what happens when we hiccup. It begins with an involuntary spasm or sudden contraction of the diaphragm, the large dome-shaped muscle below our lungs that we use to inhale air. This is followed almost immediately by the sudden closure of the vocal cords and the opening between them, which is called the glottis. The movement of the diaphragm initiates a sudden intake of air, but the closure of the vocal cords stops it from entering the windpipe and reaching the lungs. It also creates the characteristic sound, hic. To date, there is no known function for hiccups. They don't seem to provide any medical or physiological advantage. Why begin to inhale air only to suddenly stop it from actually entering the lungs? Anatomical structures or physiological mechanisms with no apparent purpose present challenges to evolutionary biologists. Do such structures serve some hidden function that hasn't yet been discovered? Or are they relics of our evolutionary past, having once served some important purpose only to persist into the present as vestigial remnants? One idea is that hiccups began many millions of years before the appearance of humans. The lung is thought to have evolved as a structure to allow early fish, many of which lived in warm, stagnant water with little oxygen, to take advantage of the abundant oxygen in the air overhead. When descendants of these animals later moved on to land, they moved from gill-based ventilation to air breathing with lungs. That's similar to the much more rapid changes faced by frogs today as they transition from tadpoles with gills to adults with lungs. This hypothesis suggests that the hiccup is a relic of the ancient transition from water to land. An inhalation that could move water over gills, followed by a rapid closure of the glottis preventing water from entering the lungs. That's supported by evidence which suggests that the neural patterning involved in generating a hiccup is almost identical to that responsible for respiration in amphibians. Another group of scientists believe that the reflex is retained in us today because it actually provides an important advantage. They point out that true hiccups are found only in mammals, and that they're not retained in birds, lizards, turtles, or any other exclusively air-breathing animals. Further, hiccups appear in human babies long before birth, and are far more common in infants than adults. Their explanation for this involves the mammalian activity. The ancient hiccup reflex may have been adapted by mammals to help release air from the stomach as a sort of glorified burp. The sudden expansion of the diaphragm would release air from the stomach, while a closure of the glottis would prevent movement from entering the lungs. Sometimes a bout of hiccups will go on and on, and we try home remedies, sipping continuously from a glass of cold water, holding one's breath, a mouthful of honey or peanut butter, breathing into a paper bag, or being suddenly frightened. Unfortunately, scientists have yet to verify that any one cure works better or more consistently than others. However, we do know one thing that definitely doesn't work.
That time.
It begins with a bit of discomfort, and soon becomes a pressing sensation that's impossible to ignore. Finally, it's all you can think about, and out of sheer desperation, you go on a hunt for a bathroom until... Humans chew urine at least 46 times a day. But occasionally, the pressures of modern life forces us to clench and hold it in. How bad is this habit, and how long can our bodies withstand it? The answers lie in the organs of the body, an oval pouch that sits inside the pelvis. Surrounding this structure are several other organs that together make up the whole urinary system. 2 kidneys, 2 ureters, 2 urethral sphincters, and a urethra. Constantly the kidneys make a mixed into two tubes called ureters. These carry it downward into the hollow organ. This organ's invisibly wall is made of tissue called the true muscle, which relaxes as the blood flows, allowing it to filtrate. As the bladder gets full, the detrusor contracts. The internal urethral sphincter automatically and involuntarily opens, and the urine is released. Whooshing downwards, the fluid enters the urethra and stops short at the external urethral sphincter. This works like a tap. When you want to delay urinating, you keep the sphincter closed. When you want to release it, you can voluntarily open the floodgates. But how do you sense your bladder's fullness so you know when to pee? Inside the layers of detrusor muscles are millions of stretch receptors that get triggered as the bladder fills. They send signals along your nerves to the sacral region in your spinal cord. A reflex signal travels back to your bladder, making the detrusor muscle contract slightly and increasing the bladder's pressure, so you're aware that it's filling up. Simultaneously, the internal urethral sphincter opens. This is called urination. The brain encounters it's not a good time to urinate by sending another signal to contract the external urethral sphincter. About 150 to 200 millimeters of urine inside it, a bladder's muscular wall is stretched. At about 400 to 500 milliliters, the pressure becomes uncomfortable. The bladder can go on stretching, but only to a point. Above 1,000 milliliters, it may burst. Most people would lose bladder control before this happens, but in very rare cases, such as when a person can't sense the need to urinate, the pouch can rupture, requiring surgery to fix. But under normal circumstances, your decision to urinate stops the brain's signal to the external urethral sphincter, causing it to relax and the bladder to empty. The external urethral sphincter is one of the muscles of the pelvic floor, and it provides support to the urethra and bladder neck. It's lucky we have these pelvic muscles, because placing pressure on the system by coughing, sneezing, laughing, or jumping could cause bladder pain. Instead, the pelvic floor muscles keep the region sealed until you're ready to go. But holding it in for too long, forcing out your urine too fast, or urinating without proper physical support may, over time, weaken or overwork that muscular system. That can lead to an overactive pelvic floor, bladder pain, urgency, or urinary incontinence. So, in the interest of long-term health, it's not a great habit to hold your pee. But in the short-term of it, your body and brain have got to keep you so you can deliberately choose your moment of sweetness. 全てを断ち切る審判の時は来た
Muscles. We have over 600 of them. They make up between 1/3 and 1/2 of our body weight. And along with connective tissue, they bind us together, hold us up, and help us move. And whether or not bodybuilding is your hobby, muscles need your constant attention, because the way you treat them on a daily basis determines whether they will wither or grow. Say you're standing in front of a door, ready to pull it open. Your brain and muscles are perfectly poised to help you achieve this goal. First, your brain sends a signal to motor neurons inside your arm. When they receive this message, they fire, causing muscles to contract and relax, which pull on the bones in your arm and generate movement. The bigger the brain's signal goes, the more motor units it rallies to help you achieve the task. But what if the goal is being something? At this point, your arm muscles alone won't be able to generate enough tension to do it. So your brain feels that other muscles are helping you tighten your belly and tense your back, generating enough force to do it. Your nervous system has just leveraged the resources you already have. Other muscles have to do. While all this is happening, your muscle fibers undergo another kind of cellular change. As you expose them to stress, they experience increased which means stress is a good thing. In response, injured cells release inflammatory factors called cytokines that activate the immune system to repair the injury. This is when the muscle building magic happens. The greater the damage to the muscle, the more your body the resulting cycle eventually makes muscles bigger as they adapt for resting. Since our bodies are already adapted to those people don't produce enough stress to stimulate new muscle growth. So to build new muscle, a process called hypertrophy, our cells need to be exposed to higher workloads than they are used to. In fact, if you don't continuously expose your muscles to some resistance, they will shrink, a process known as muscular atrophy. In contrast, exposing the muscle to a high degree of tension, especially while the muscle is lengthening, also called an eccentric contraction, generates effective conditions for new growth. However, muscles rely on more than just activity to grow. Without proper nutrition, hormones, and rest, your body would never be able to repair damaged muscle fibers. Protein in our diet preserves muscle mass by providing the building blocks for new tissue in the form of amino acids. Adequate protein intake, along with naturally occurring hormones like insulin-like growth factor and testosterone, help shift the body into a state where tissue is repaired and grown. This vital repair process mainly occurs when we're resting, especially at night while sleeping. Gender and age affect this repair mechanism, which is why young men with more testosterone have a leg up in the muscle building game. Genetic factors also play a role in one's ability to grow muscle. Some people have more robust immune reactions to muscle damage and are better able to repair and replace damaged muscle fibers, increasing their muscle building potential. The body responds to the demands you place on it. If you tear your muscles up, eat right, rest, and repeat, you'll create the conditions to make your muscles as big and strong as possible. It is with muscles as it is with meaningful growth requires challenge and stress. Also known as the long impact. This muscular organ is split into four sections: the ascending, transverse, descending, and sigmoid colon, which connects with the rectum and anus. The small intestine delivers stool, consisting of ingested food, bile, and digestive juices to the large intestine. As this stool moves through the colon, the organ siphons off most of the water it contains, transforming it from liquid to solid. The longer this transmission takes, the more reabsorption results in solid solution. Once it reaches the sigmoid colon, finding out of reabsorption.
Ủa sao biết?
The purorectalis forms a sling-like formation called and when you voluntarily relax desire to visit that is to body. Usually there's no factors behind this problem. The stool is slow movement through the colon and or pelvic floor descent.
Gọi là xí chết luôn.
Which makes the stool dry. Both of these problems
Cái rót cuối không bắn trúng được cái điểm yếu của nó.
more acute. and it becomes difficult to expel
美
waste.
しい世界を決戦の時が来た
Researchers have developed methods such as the crystal stool chart. Most people who look at that chart will be able to tell they've experienced constipation before. When you're on the toilet, you should ideally be in a squatting position. With your buttocks firmly on the toilet seat, you can elevate your feet on a stool and lean forwards with a straight back, which straightens the anorectal angle and eases the passage of waste.
美しい世
Going
界
a
を
day
câu nào bảo là AVC boost đâu?
necessarily cause a reward. But if you are experiencing simple dietary and lifestyle changes, regular exercise, abdominal massage, and 6 cups of water,
このレッド全てを断ち切る
check this place.
審判の時は来た
If you lined up all the blood vessels in your body, they'd be 95,000 kilometers long. And every day, they bring the equivalent of over 7,500 liters of blood. Though that's actually the same 4 or 5 liters recycled over and over, delivering oxygen and
Biết đâu
precious
đánh đại.
nutrients like glucose and amino acids to the body's tissues. All that blood exerts a force on the muscular walls of the blood vessels. That force is called blood pressure, and it rises and falls with the phases of the heartbeat. It's highest during systole, when the heart contracts to force blood through the arteries. This is your systolic blood pressure. When the heart is at rest between beats, blood pressure falls to its lowest value, the diastolic pressure. A typically healthy individual produces a systolic pressure
Rồi đi quần hoắc đấy.
120 millimeters of mercury, and diastolic pressure between 60 and 80. Taken together, a normal reading is a bit less than 120 millimeters. The blood traverses the landscape of the body through the pipes of the
審判
circulatory
の時
system.
は来た
In any plumbing system, several things can increase the force on the walls of the pipes. Bodies of fluid, extra fluid,
Vãi lều
or
nó đánh.
narrower pipes.
Đánh chết con
So if
HOF
the
luôn.
blood thickens, a higher
lờ.
pressure is needed
Nó
to
đánh
push it.
chết cả con HOF luôn.
審判の時は来た
A high salt diet will lead to a similar result. The salt promotes water retention, and the extra fluid increases the blood volume and blood pressure. And stress, like the fight or flight response, releases hormones like epinephrine and norepinephrine.
Má nó đánh chết cả HOF luôn.
Restricted through vessels,
Thiếu thể tin được.
increasing the resistance to flow and raising the pressure upstream. Blood vessels can usually handle these fluctuations easily. Elastic fibers embedded in their walls make them resilient. But if your blood pressure regularly rises above about 140 or 90, what we call hypertension, and stays there, it can cause serious problems. That's because the extra strain in the arterial wall can produce small tears. When the injured tissue swells up, substances that respond to inflammation, like white blood
Ai tự
cells,
sát ở đây chứ?
collect around the tears.
Tự sát luôn rồi mà.
Fat and
Đâu đủ SP
cholesterol
đâu.
floating in the blood latch on too, eventually building up to form a plaque that stiffens and thickens the inner arterial wall. This condition is called atherosclerosis, and it can have dangerous consequences. If the plaque ruptures, a blood clot forms on top of the tear, clogging the already narrowed pipe. If the clot is big enough, it can completely block the flow of oxygen and nutrients to cells downstream. In vessels that feed the heart, that will cause a heart attack when oxygen-deprived cardiac muscle cells start to
審判の
die.
時は来た
If the clot cuts off blood flow to the brain, it causes a stroke. Dangerously clogged blood vessels can be widened by a procedure called an angioplasty. There, doctors thread a wire through the vessel to the obstructed site, and then pass a deflated balloon catheter over the wall. When the balloon is inflated, it forces the passage of the opening. Sometimes a rigid tube called a stent is placed in the vessel to help hold it open, letting the blood flow freely to replenish the oxygen-starved cells downstream. Staying flexible under pressure is a tough job for arteries. The fluid they pump is composed of substances that can get sticky and clog them.
The fuck?
And your typical healthy heart beats about 70 times a minute and at least 2.5 billion times during an average lifetime. That may sound like an insurmountable amount of pressure, but don't worry, your heart is for the challenge.
Dead.
また勝ったよ。見てくれてるよね。
Ah, dead.
For most of history, humans had no idea what purpose the heart served. In fact, the organ so confused Leonardo da Vinci that he gave up studying it. Although everyone could feel their own heart beating, it wasn't always clear what each thump was achieving. Now we know that the heart pumps blood. But that fact wasn't always obvious, because if a heart was exposed or taken out, the body would perish quickly. It's also impossible to see through the blood vessels. And even if that were possible, the blood itself is opaque, making it difficult to see the heart valves working. Even in the 21st century, only a few people in surgery teams have actually seen a working heart.
That doesn't look so
Internet
right.
searches for heart function point to crude models, diagrams, or animations that don't really show how it works. It's as if there's been a centuries-old conspiracy amongst teachers and students to accept that heart function cannot be demonstrated, meaning that the next best thing is simply to cut it open and label the parts. That way, students might not fully grasp the way it works, but can superficially understand it, learning such concepts as the heart is a whole chain reaction, or potentially misleading statements like mammals have a
Thế thôi.
one big blood vessel to the lungs and back, and another to the body and back. In reality, mammals have a figure-8 circulation. Blood goes from one heart pump to the lungs, back to the second heart pump, which sends it to the body, and then back to the first pump. That's an important difference, because it marks two different morphologies. This confusion makes many students wary of the heart in biology lessons, thinking it signals an intimidating subject full of complicated names and diagrams. Only those who end up studying medicine completely understand how it all actually works. That's when its functions become apparent, as medics get to observe the motion of the heart's valves. So let's imagine you're a medic for a day. What you'll need to get started is a whole fresh heart, like one from a sheep or pig. Immerse this heart in water, and you'll see that it doesn't pump when squeezed by hand. That's because water doesn't enter the heart cleanly enough for the pumping mechanism to work. You can solve this problem in an extraordinarily simple way. Simply identify the two atria and cut them off, extruding the tops of the ventricles. This makes the heart look less complicated, because the atria have several incoming veins attached, so without them there, the only vessels remaining are the two major heart arteries, the aorta and pulmonary artery, which rise like white columns in between the ventricles. It looks, and really is, very simple. If you run water into the right ventricle from a tap, the left also works, but less spectacularly, you'll see that the ventricular valve tries to close against the incoming stream, and the ventricle inflates with water. Squeeze the ventricle, and a stream of water squirts out of the pulmonary artery. The ventricular
Open the
valve,
lid,
called the
you
right
model.
ventricle in the right ventricle and the mitral in the left, can be seen with the water opening and closing like parachutes as the ventricle is rhythmically expanding. This flow of water mimics the flow of blood in life. The valves are completely deficient. You'll notice they don't leak at all when the ventricles are squeezed.
Wow, dead.
Over time, they also
I think I
close
can get
against each
somewhere
other with very
close
little
to
wear and
600
tear,
only.
which explains how this mechanism continues to work seamlessly
Just
for more
close
than
to
2 billion beats a heart gives in its lifetime. Now, anyone studying the heart can hold one in their hands, make it pump for real, and watch the action unfold. So place your hand
Chung
above
gần
your own
600 là cao.
and feel its rhythmic beat.
Vãi lù EV.
Understanding how this dependable inner pump works
Holy shit.
gives new resonance to the feeling you get when you run a race, drink too much
Holy
caffeine,
shit.
or catch the eye of the one you love.
Dead. Thôi, hẹn gặp khác.
There's a factory inside you that weighs about 1.4 kilograms and runs for 24 hours a day. This is your liver, the heaviest organ in your body, and one of the most crucial. This industrious structure simultaneously acts as a storehouse, a manufacturing hub, and a processing plant. And each of these functions involves so many important subtasks that without the liver, our bodies would simply stop working. One of the liver's main functions is to filter the body's blood, which it receives in regular shipments from two sources. The hepatic artery delivers blood from the heart, while the hepatic portal vein brings it from the intestine. This double delivery fills the liver with nutrients that it then sorts, processes, and stores with the help of thousands of tiny internal processing plants known as lobules. Both blood flows also deliver the oxygen that the liver needs to function. The blood that is received from the intestine contains carbohydrates, fats, and vitamins and other nutrients dissolved in it from the food you've consumed. These must be processed in different ways. In the case of carbohydrates, the liver breaks them down and converts them into sugars for the body to use as energy when the filtered blood is sent back out. Sometimes the body has leftovers of nutrients that it doesn't immediately require. When that happens,
có Raven mà, nhưng mà đánh bãi thì cầm Terry thôi. Terry hoặc là RC cho nhanh thôi chứ cầm Raven lâu vãi liền.
But the blood flowing into the liver isn't always full of good things. It also contains toxins and byproducts that the body can't use, and the liver monitors these strictly. When it spots a useless or toxic substance, it either converts it into a product that can't hurt the body, or isolates it and whisks it away, channeling it to the kidneys and intestine to be excreted. Of course, we wouldn't consider the liver a factory if it didn't also manufacture things. This organ makes everything from various blood plasma proteins that transport fatty acids and help form blood clots, to the cholesterol that helps the body create hormones. It also makes vitamin D and substances that help digest. But one of the most powerful products is bile, like an eco-friendly As it's produced, bile is funneled into a small container below the liver called gallbladder before being trickled into the intestine to help break down fats. Bile also helps carry other toxins and byproducts but such a complex system runs smoothly by keeping more toxins than This is one factor we consider
Ủa sao con này OT không có gây trauma gì hết vậy? Địt mẹ cũng nhầm. Má nhầm bằng Sirin. Nhục quá. Nhìn nhầm Bella bằng Sirin. Ở sao đầm rồi sao không có trauma?
In ancient Greece, headaches were considered powerful afflictions. Victims prayed for relief from Asclepius, the god of medicine. And if pain continued, a medical practitioner would perform the best known remedy, drilling a small hole in the skull to drain the blood. This dire technique, called trepanation, often replaced the headache with a more condition. Fortunately, doctors today don't resort to power tools to cure headaches, but we still have a lot to learn about this ancient ailment. Today, we classify headaches into two camps: primary headaches and secondary headaches. The former are not symptomatic. They are but we'll come back to them in a minute, because while primary headaches account for 50% of reported cases, we actually know much more about secondary headaches. These are caused by other health problems, with triggers ranging from dehydration and caffeine withdrawal to head and neck injury and heart disease. Doctors have classified over 150 diagnosable types, all with different causes, symptoms, and treatments. But we'll take just one common case, a sinus infection, as an example. The sinuses are a system of cavities that spread behind our foreheads, noses, and cheeks. When our sinuses are infected, Our immune response heats up the area, roasting the bacteria, inflaming the cavities, wetting the acid-dirty subside. The engorged sinuses put pressure on the cranial arteries, as well as muscles in the head. Their pain receptors, called nociceptors, trigger in response, getting the brain to release a flush of peptides that inflame the cranial blood vessels, swelling and cleaning up the head. This discomfort paired with hypersensitive epilepsy creates the sore, throbbing pain of a headache. Not all headache pain comes from swelling. Tense muscles and inflamed sensitive nerves cause varying degrees of discomfort in each headache. But all cases are reactions to self-inflaming influences. While the cause is clear in secondary headaches, the origins of primary headaches remain unknown. Scientists are still investigating potential triggers for the three types of primary headaches: recurrent, long-lasting migraines, painful, rapid-fire cluster headaches, and most common of all, the tension headache. As the name suggests, tension headaches are known for creating the sensation of a tight band squeezed around the head. These headaches increase the tenderness of the pericranial muscles, which then painfully pulse blood and oxygen. Patients report stress, exertion, and hormone changes as triggers, but these don't fit the symptoms quite right. For example, in dehydration headaches, the frontal lobe actually shrinks away from the skull, creating forehead swelling that doesn't match the location of the pain in tension headaches. Scientists have theories for what the actual cause is, ranging from spasming blood vessels to overly sensitive nociceptors, but no one knows for sure. Meanwhile, most headache research is focused on more severe migraines are recurring headaches which create a vice-like sensation on the skull that can last from 4 hours to 3 days. In 20% of cases, these attacks are intensive to overload the brain with electrical energy, which hyperexcites sensory This produces hallucinations called organs, which can include seeing flashing lights and geometric patterns and experiencing tingling sensations. Cluster headaches, another primary headache type, cause burning, stabbing bursts of pain behind one eye, leading to a red eye, constricted pupil, and even eye. What can be done about these conditions, which dramatically affect many people's quality of life? Tension headaches and most secondary such as anti-inflammatory drugs that reduce renal swelling, and many secondary headache triggers like dehydration, exhaustion, and stress can be proactively avoided. Migraines and cluster headaches are more common, and we haven't yet discovered reliable treatments that work for everyone. But thankfully, pharmacologists and neurologists are hard at work cracking these
Mày làm to thế nhỉ? Cho xuống sen thôi. Chưa, Raven thì vẫn đang còn ngon, nhưng mà đánh bãi thì cầm con này cho nhanh. Cầm Raven lâu lắm.
You can download an audio version of this book for free at audible.com/TEDED. Every free trial created encourages Audible to continue supporting TEDED
Xong
nonprofit
thì hit rồi, bú luôn mất SP luôn. Sao nó lại trông như thế này?
Across the whole planet, humans eat on average between 1 and 2.7 kilograms of food a day. That's over 365 kilograms a year per person, and more than 28,800 kilograms over the course of a lifetime. And every last scrap makes its way through the digestive system. Comprised of 10 organs covering 9 years, cell types. This is one of the most diverse and complicated systems in the body. To perform a singular task, transforming the raw
What the fuck? What the fuck?
The digestive system has 4 phases. First, there's the gastrointestinal tract. This is transports your food as an internal surface area. Enough to cover half of that. Second, there's the process of a shooting organ to break down food using an array of special juices. Third, the body's enzymes,
Sheesh.
hormones,
Welcome,
nerves,
welcome.
and blood all work together to break down food, modulate the digestive process, and deliver its final products. Finally, there's the mesentery, a large stretch of tissue that supports and positions all your digestive organs in the abdomen,
Sniping time.
enabling them to do their jobs.
Extra.
The digestive process
Bam.
begins before food even hits your tongue. Anticipating a tasty morsel, glands in your mouth start to pump out saliva. We produce about 1.5 liters of this liquid each day. Once inside your mouth, chewing combines with the sloshing saliva to turn food into a moist lump called the bolus. Enzymes present in the saliva break down any starch. Then your food finds itself at the rim of a 25-centimeter long tube called the esophagus, down which it must plunge to reach the stomach. Nerves in the surrounding esophageal tissue sense the bolus's presence and trigger peristalsis, a series of parts that propels the food into the stomach, where it's producing stomach walls. By cells acids and enzyme-rich juices that start to dissolve. These hormones also alert the pancreas, liver, and gallbladder to produce digestive juices
You don't
and
even need to do
transfer
that.
bile, a yellowish-green liquid that digests fat, in preparation for the next stage. After 3 hours inside the stomach, the once shapely bolus is now a frothy liquid
What's the
called
art of
chyme,
people seeing
and
you
it's ready to
sniping?
move into the small intestine. The liver sends bile to the gallbladder, which secretes it into the first portion of the small intestine, called the duodenum. Here, it dissolves the fats floating in the slurry of chyme
Do I need
so
to
they can be
use,
easily digested by the pancreatic and
avocado
intestinal juices that have
美
leached
しい
onto
世
the
界
scene.
への審判の時は来た
Enzyme-rich juices break the fat molecules down into fatty acids and glycerin for easier absorption into the body. The enzymes also carry out the final deconstruction of proteins into amino acids and carbohydrates into glucose. The small intestine functions, the jejunum and ileum, which are included in millions of nutrients called so again, which serves to maximize molecular absorption. The body takes them on the final
全てを断ち切る
to feed the body's organs and tissues. But it's not done quite yet. Leftover fiber, water, and dead cells sloughed off during digestion make it into the large intestine, also known as the colon. The body drains out most of the remaining fluid through the intestinal wall. What's left is a soft mass called stool. The colon squeezes this byproduct into a pouch called the rectum, where nerves sense it expanding and tell the body when it's time to expel the waste. The byproducts of digestion exit through the anus, and the food's long journey typically lasts 10N is a nonprofit. If you value our work, please consider supporting it on patreon.com/10N.
このレッ
Wow, that
スン全てを断ち切る
Like any machine, it consists of specialized components and requires a trigger to start functioning. Here, the components are the structures and tissues making up the
美しい
lungs,
世界を
as
守
well
る
as the various other respiratory organs connected to them. And to get this machine moving, we need the autonomic
美しい
nervous
世界
system,
の決戦の時が来た
as a control center for the vital functions.
木を見て
As
動
the
き
body prepares
Wow,
to
that-
take in oxygen-rich air, This
美
system
しい
sends a
世界
signal
の
to
審判の時は来た
flattening the diaphragm and contracting the intercostal muscle to create more space for the lungs to expand. Into the
Oops.
bronchi that split at the
Missed.
trachea's base, with one entering each lung. Like
美しい
tree
世
branches,
界の審判の時は来た
thousands of tiny capsules called bronchioles. It's tempting to think of the lungs as huge balloons, but instead of being hollow, they're actually sponges, with the bronchioles running throughout the lungs. At the end of each bronchiole, called the capillaries, capillaries hold dioxide, and the air sacs are full of oxygen. The molecules of this gas lower concentration. So as oxygen crosses over to the capillaries, the hemoglobin grabs it up, while the carbon dioxide is unloaded into the lungs. The oxygen-rich hemoglobin is then transported throughout the body via the bloodstream. But what do our lungs do with all that carbon dioxide? Exhale it, of course. The autonomic nervous system kicks in again, causing the diaphragm to ball up, and the intercostal muscles to the carbon dioxide rich air is recycled into oxygen. That's how we see the organs in our bodies efficiently supplied. Lungs inhale and exhale.
全てを断ち切る
10,000 liters of air each day. That's a lot of air. Don't sweat. As long as the autonomic nervous system has got it.
私に追いつけるかすぐに楽にしてやる現状の光私と
Nestled in the tissues of your neck is a small, unassuming organ that wields enormous power over your body. It's called the thyroid. Like the operations manager in a company, its role is to make sure that the cells in your body are working properly. It does
Damn,
that by
that-
using hormones to deliver messages to every single one of them. This high-ranking organ is made up of globules that each contain smaller cells called follicles, which store the hormones the thyroid sends out into your blood. Two of the most important hormones it produces are thyroxine and triiodothyronine, or T3 and
美しい
T4.
世界の審判の時は
As
来た
messengers, the hormone's job is to instruct every cell in the body when to consume oxygen and nutrients. That maintains the body's metabolism,
Nope.
the series of reactions our cells perform to provide us with
美
energy.
しい世界の
This
審判の時は
hormonal
来た
notification from the thyroid gets the heart pumping more efficiently and makes our cells break down nutrients faster. When you need more energy, the thyroid helps by sending out hormones to increase metabolism. Ultimately, the
What
thyroid
the
allows
hell?
our cells to use energy, grow, and reproduce.
Why so far away?
美しい世界の審判の
The
時は来た
thyroid is controlled by the pituitary gland, a hormonal gland deep in the brain that oversees the thyroid's tasks, making sure it knows when to send out its messengers. The pituitary's role is to sense if hormone levels in the blood are too low or too high, in which case it sends out instructions in the form of the thyroid-stimulating hormone. Even in this tightly controlled system, however, management sometimes slips up. Certain diseases, growths in the thyroid, or chemical imbalances in the body can confuse the organ and make it deaf to the pituitary's guiding commands. The first problem this causes is hyperthyroidism, which happens when the organ sends out too many hormones. That means the cells are overloaded with instructions to consume nutrients and oxygen. They become overactive as a result, meaning a person with hyperthyroidism experiences a higher metabolism, signaled by a faster heartbeat, constant hunger, and rapid weight loss. They also feel hot, sweaty, anxious, and find it difficult to sleep. The opposite problem is
Why is it so hard to
hypothyroidism,
suicide when I
which
want
happens
to?
when the thyroid sends out too few hormones. meaning the body's cells don't have as many messengers to guide them. In response, cells grow listless and metabolism slows. People with hypothyroidism see symptoms of weight gain, sluggishness, sensitivity to cold, swollen joints, and feeling low. Luckily, there are medical treatments that can help trigger the thyroid's activities and bring the body back to a steady metabolic rate. For such a little organ, the thyroid wields an awful lot of power. But a healthy thyroid manages our cells so effectively that it can keep us running smoothly without us even noticing it's there.
Ước gì?
出発です。すぐに楽にしてやる。
A mosquito lands on your arm, injects its chemicals into your skin, and begins to feed. You wouldn't even know it was there if not for the red lump that appears, accompanied by a telltale itch. It's a nuisance, but that lump is an important signal that you're protected by your immune system, your body's major safeguard against infection, illness, and disease. This system is a vast network of cells, tissues, and organs that coordinate your body's defenses against any threats to your health. Without it, you'd be exposed to billions of bacteria, viruses, and toxins that could make something as minor as a paper cut or a seasonal cold fatal. The immune system relies on millions of defensive white blood cells, also known as leukocytes, that originate in our bone marrow. These cells migrate into the bloodstream and the lymphatic system, a network of vessels which helps clear bodily toxins.
What the hell?
Our bodies are teeming with leukocytes. There are between 4,000 and 11,000 in every microliter of blood. As they move around, leukocytes work like security personnel, constantly screening the blood, tissues, and organs for suspicious signs. This system mainly relies on cues called antigens. These molecular traces on the surface of pathogens and other foreign substances betray the presence of invaders. As soon as the leukocytes detect them, it takes only minutes for the body's protective immune response to kick in. Threats to our bodies are hugely variable, so the immune response has to be equally adaptive. That means relying on many different types of leukocytes to tackle threats in different ways. Despite this diversity, we classify leukocytes in two main cellular groups, which coordinate a two-pronged attack. First, phagocytes trigger the immune response by sending macrophages and dendritic cells into the blood. As these circulate, they destroy any foreign cells they encounter, simply by consuming them. That allows phagocytes to identify the antigen on the invaders they just ingested and transmit this information to the second major cell group orchestrating the defense, the lymphocytes. A group of lymphocyte cells called T cells go in search of infected body cells and swiftly kill them off. Meanwhile, B cells and helper T cells use the information gathered from the unique antigens to start producing special proteins called antibodies. This is the pièce de résistance. Each antigen has a unique matching antibody that can latch onto it like a lock and key and destroy the invading cells. B cells can produce millions of these, which then cycle through the body and attack the invaders until the worst of the threat is neutralized. While all of this is going on, familiar symptoms like high temperatures and swelling are actually processes designed to aid the immune response. A warmer body makes it harder for bacteria and viruses to reproduce and spread because they're temperature sensitive. And when body cells are damaged, they release chemicals that make fluid leak into the surrounding tissues, causing swelling. That also attracts phagocytes, which consume the invaders and the damaged cells. Usually, an immune response will eradicate a threat within a few days. It won't always stop you from getting ill, but that's not its purpose. Its actual job is to stop a threat from escalating to dangerous levels inside your body. And through constant surveillance over time, the immune system provides another benefit. It helps us develop long-term immunity. When B and T cells identify
I'm gonna
antigens, they
save it
can
there.
use that information to recognize invaders in the future.
So
when a threat revisits, the cells can swiftly deploy the right
Bam.
antibodies to tackle it
Bam.
before it affects any more cells. That's how you can develop immunity to certain diseases, like chickenpox. It doesn't always work so well.
what?
Some people have autoimmune diseases, which trick the immune system into attacking the body's own perfectly healthy cells. No one knows exactly what causes them, but these disorders sabotage the immune system to varying degrees and underlie problems like arthritis, type 1 diabetes, and
Bam.
multiple sclerosis. For most individuals, however, a healthy immune system will successfully fight off an estimated 300 colds and innumerable other potential infections over the course of a lifetime. Without it, those threats would escalate into something far more dangerous. So the next time you catch a cold or scratch a mosquito bite, think of the immune system. We owe it our lives. TED-Ed is a
Yeah.
nonprofit. If you value our work, please consider supporting it on patreon.com/TEDEd.
It's a hot day, and you've just downed several glasses of water, one after the other. Behind the sudden urge that follows are two bean-shaped organs that work as fine-tuned internal sensors. They balance the amount of fluid in your body, detect waste in your blood, and know when to release the vitamins, minerals, and hormones you need to stay alive. Say hello to your kidneys. The main role of these organs is to dispose of waste products and to turn them into urine. The body's 8 liters of blood pass through the kidneys between 20 and 25 times each day, meaning that together, these organs filter about 180 liters every 24 hours. The ingredients in your blood are constantly changing as you ingest food and drink, which explains why the kidneys need to be on permanent duty. Blood enters each kidney through arteries that branch and branch until they form tiny vessels that entwine with special internal modules
Holy
called
shit.
nephrons. In each kidney, 1 million of these nephrons form a powerful array of filters and sensors that carefully sift through the blood. This is where we see just how refined and accurate this internal sensing system is. To filter the blood, each nephron uses 2 powerful pieces of equipment,
Autophilix.
a blob-like structure called a glomerulus, and a long stringy straw-like tubule. The glomerulus
Does it
works
hurt
like a
her?
sieve, allowing only certain ingredients, such as vitamins and minerals, to pass into the tubule. Then, this vessel's job is to detect whether any of those ingredients are needed in the body. If so, they're reabsorbed in amounts that the body needs so they can circulate in the blood again. But the blood doesn't only carry useful ingredients. It contains waste products too, and the nephrons have to figure out what to do with them. The tubules sense compounds the body doesn't need, like urea, left over from the breakdown of protein, and redirects them as urine out of the kidneys
Wait,
and
what?
through 2
Where's the
long
QT?
sewers called ureters.
Is it even
These
on?
tubes empty their contents into the bladder to be
Oh, it's
discharged,
off.
ridding your body of that waste once and for all. There's water in that urine too. If the kidney detects too much of it in your blood, for instance, when you've chugged several glasses at once, it sends the extra liquid to the bladder to be removed. On the other hand, low water levels in the blood prompt the kidney to release some back into the bloodstream, meaning that less water makes it into the urine. This is why urine appears yellower when you're less hydrated. By controlling water, your kidneys stabilize the body's fluid levels. But this fine balancing act isn't the kidney's only skill. These organs have the power to activate vitamin D to secrete a hormone called renin that raises blood pressure, and another hormone called erythropoietin, which increases red blood cell production. Without the kidneys, our bodily fluids would spiral out of control. Every time we ate, our blood would receive another load of unsifted ingredients. Soon, the buildup of waste would overload our systems and we'd expire. So each kidney not only keeps things running smoothly, it also keeps us alive. Lucky then that we have 2 of these magical beings.
I don't know if it's even good to
Each
turn
time you
on
take a
Felix
step,
QTE.
200 muscles work in unison to lift your foot, propel it forward, and set it down. It's just one of the many thousands of formed by the muscular system. This network of over 650 muscles covers the body and is the reason we can blink, smile, run, jump, and stand upright. It's even responsible for the heart's dependable thumb. First, what exactly is a muscle? It's made up of 3 main muscles: skeletal muscle, cardiac muscle, which is only found in and smooth muscle, which lines the blood vessels in certain organs, like the intestine and uterus. All 3 types are made up of muscle cells, also known as fibers, bundled tightly together. These bundles receive signals from the nervous system that contract the fibers, which in turn generates force and motion. This produces almost all the movements we make. Some of the only parts of the body whose motions aren't governed by the muscular system
Oh
are
shit, I have
sperm
to turn
cells,
off
the hair-like cilia in our airways, and certain white blood cells. Muscle contraction can be split into 3 main types. The first 2, shortening muscle fibers and lengthening them, generate opposing forces. So the biceps will shorten while the triceps will lengthen or relax, pulling up the arm and making it bend at the elbow. This allows us to, say, pick up a book, or if the muscle relationship is reversed, put it down. This complementary partnership exists throughout the muscle system. The third type of contraction creates a stabilized muscle. In these cases, the muscle fibers don't change in length, but instead become rigid. This allows us to grip a mug of coffee or lean against a wall. It also maintains our posture by holding us upright. Skeletal muscles form the bulk of the muscular system, make up about 30 to 40% of the body's weight, and generate most of its motion. Some muscles are familiar to us, like the pectorals and the biceps. Others may be less so, like the bicep, a muscle that attaches your cheek to your chin, where the body's tiny skeleton are 1 millimeter long tube, called the stem, that's nestled deep inside the humerus. Wherever they occur, skeletal muscles are connected to the somatic nervous system, which gives us almost complete control over their movement. This muscle group also contains 2 types of muscle fibers to refine our motions even further: slow twitch and fast twitch. Fast twitch fibers react instantly and quickly, but quickly use up their energy to clear out. Slow twitch fibers, on the other hand, are enduring cells. They react and use energy slowly, so they can work for longer periods. A sprinter will accumulate more fast twitch muscles in her legs through continuous practice,
Oh shit,
enabling her to
not enough
quickly,
SP.
if
Hi,
briefly,
yeah.
pick up the pace. Whereas back muscles contain more slow twitch muscles to maintain your posture all day. Unlike the skeletal muscles, the body's cardiac and smooth muscles are managed by the autonomic nervous system, beyond our direct control.
Holy shit.
Your heart thump roughly 3
No
million times
fucking
over the
SP.
course of your life,
I'm dead.
which supplies the body with blood and oxygen. Autonomic control also contracts and relaxes smooth muscle in a rhythmic cycle. That pumps blood to the smooth internal walls of blood vessels, enables the intestine to constrict and push food through the digestive system, and allows the uterus to contract when a person is giving birth. As muscles work, they also use energy and produce an important byproduct: heat. In fact, muscle provides about 85% of your warmth, which the heart and blood vessels then spread evenly across the body. Without that, we couldn't maintain the temperature necessary for our survival. The muscular system may be largely invisible, but it leaves its mark on almost everything, whether it's the blink of an eye or a race to the finish line. This video is made possible by our community on Patreon. And if you're curious about the human body, check out this playlist.
5秒進す万物となるガラスバイタの審判の時は来た
Beneath your ribs, you'll find, among other things,
みんなの
the
祝福を胸に
pancreas, an organ that works a lot like a personal health coach. This organ controls your sugar levels and produces a special juice that releases the nutrients from your food to help keep you in the best possible shape. The pancreas sits just behind your stomach, an appropriate home, as one of its jobs is to break down the food you eat. It aids digestion by producing a special tonic made of water, sodium bicarbonate, and digestive enzymes. Sodium bicarbonate neutralizes the stomach's natural acidity, so these digestive enzymes can perform their jobs. Lipase breaks down fatty substances. Protease splits up proteins. And amylase divides carbohydrates to create energy-rich sugars. Most of those nutrients then get absorbed into the bloodstream and go on to enrich the body. While all this is happening, the pancreas works on another critical task: controlling the amount of sugar in your blood. It achieves this with the hormones insulin and glucagon, which are produced in special cells called the islets of Langerhans. Having too much or too little sugar can be life-threatening, so the pancreas must stay on constant alert. After a big meal, the blood often becomes flushed with sugar. To bring us back to normal, the pancreas releases insulin, which makes the excess sugar move into cells where it's either used as an energy source or stored for later. Insulin also tells the liver to shut down sugar production. On the other hand, if blood sugar is low, the pancreas releases a hormone called glucagon that tells the body's cells and liver to release stored sugars back into the bloodstream. The interplay between insulin and glucagon is what keeps our sugar levels balanced. But the pancreas can no longer coach us like this, meaning that this healthy balance is destroyed. If it's weakened by disease, the organ's ability to produce insulin may be reduced or even destroyed, which can trigger the condition known as diabetes. Without regular insulin release, sugar steadily builds up in the blood, eventually hardening the blood vessels and causing heart attacks, kidney failure, and strokes. The same lack of insulin deprives cells of the energy-rich sugar they need to grow and function. People with diabetes also tend to have higher levels of glucagon, which makes even more sugar circulate. Without this internal health coach, our sugar levels would go haywire, and we wouldn't be able to digest important nutrients. But like any coach, it's not the pancreas's job alone to keep us healthy. It needs our conscious participation too.
They skipped the first ultimate or what? How the fuck?
美しい世界より審判の時は来た時期を見て動きました
Between you and the rest of the world lies an pancreas that makes up 60% of the weight. This is your skin, the largest organ in your body. Laid flat, covered close to 1.7 It plays a surprising role in basics. Skin is the foundation of the nutrition system. It also incorporates your hair, nails, and specialized glands and nerves. Made up of 3 layers, the epidermis, dermis, and hypodermis, skin's thickness varies from 0.5 millimeters at its thinnest and up to 4 millimeters at its thickest. It also carries out 3 key functions: protecting, regulating, and sensing the world.
5秒進す万物となる
Its huge surface processes hundreds of thousands of relying mostly on water. In your food, there are
このレッカー
50
全てを出し切る
Damn, how?
When these cells move upwards, they're filled with a hardened protein called keratin. Once they reach the surface, they form a tightly overlapping waterproof layer that's difficult for invading microbes to breach. Any harmful microbes that make it into the epidermis will encounter Langerhans cells. This group of protective skin cells detects invaders and communicates their presence to.
I'm gonna take a shower. See you tomorrow. Eat.